This is similar to Module 7, Problem 2 on U substitution with a square root. A lot of people had a difficulty with this, deciding what to use for U. So one thing to try with a square root is to let U be the amount underneath the square root. So let's let U equal 3x squared plus 5. And then du would be the derivative of this, 3x squared, we pull down the 2 times 3 is 6x, and then derivative of 5 is 0, so 6x dx is du. Now when we do U substitution, the thing that is kind of tricky is making sure that every piece is accounted for when we rewrite our integral. So we need to make sure that the x is taken care of. We need to make sure that the square root shows up there somewhere, that what's under the square root shows up, that dx is taken care of. So in order to do that, one way is to solve for dx in this equation. So to solve for dx, we would divide by 6x on both sides to get dx equals du over 6x. And now let's start replacing things in the original integral. So that means we have integral. We haven't done anything with this front x just yet, so we're just going to rewrite it. So x square root of, we can replace 3x squared plus 5 with our substitution u, and then we can replace dx with du over 6x. But we can't do the integral yet with, or the antiderivative with all of these different variables. So we want to try to simplify this so that we only have one variable showing up, and that is u. So we can see that this front x is taken care of by a division by x here. So we can cancel those. And then we have this divided by 6, or 1/6. Since that's a constant, we can write it out front of the integral. So now we have 1/6 integral square root of u du. So that's what I mean when I say that we need to make sure that the x is taken care of. And if we choose our U substitution correctly, and we can use U substitution, that really should happen, hopefully, with the dx when we plug that back in. So now we can integrate here. So that's 1/6 integral, I'm going to rewrite it as u to the 1/2 because square root is the same as power 1/2 du. To integrate using the reverse power rule, we add 1 to the power. So that would be 1/6 u to the 3/2 when we add 1 to the power, divided by the new power, so divided by 3/2 plus a constant. And this is looking kind of messy. So that would be 1/6. Instead of divided by 3/2, I'm going to write that as multiplied by 2/3. Because if we divide by a fraction, we could write it as multiplying by the reciprocal. U to the 3/2 plus c. Okay, which is 2 over 18 u to the 3/2 plus c, which we can simplify to 1/9 u to the 3/2 plus c. And now our last step is to plug back in our original function for u, which is 3x squared plus 5. So our final answer should be 3x squared plus 5 to the 3/2 power over 9 plus a constant c. So I do recommend that you go back and try problem 2 with these steps of choosing u to be the amount under the square root, and then hopefully you'll get it to the point of finding the antiderivative of square root of u du.